So what we have here is a block of mass m equal to 0.032 kilograms that can slide along this frictionless loop, and it is given that the radius r is equal to 12 centimeters. Now the block is released from rest at point P at height h equal to 5r above the bottom of the loop, and the first and second questions are: how much work does the gravitational force do on the block as the block travels from point P to point Q and also from point P to the top of the loop? So let us make use of the universal equation W is equal to minus delta U, or the work done by a force is equal to minus of the change in potential energy. Now, why I call this a universal equation is simply because this equation applies to change in any form of potential energy. That is, it could be gravitational potential energy or spring potential energy and so on and so forth. So expanding this equation, we get work done by gravity is equal to minus U final minus U initial, which equals minus mg h final, that is the final height, minus mg h initial. Or for part A, we can write work done by gravity is equal to minus mg r minus mg 5r, which gives work done by gravity is equal to 4 times mgr. Now here all the quantities are known, and if we substitute the values, we get work done by gravity is equal to 0.15 joules. Now you could have approached this problem in another way, that is going by the very basic equation, that is work done by gravity is equal to the dot product of force of gravity and the displacement. Now while we can see that the displacement in this case is this, but we also need to remember that the force of gravity is a conservative force, and therefore the work done in moving from here to here or from here to here is the same. That is, as long as the elevation change is the same, it does not matter if the box is here or even here. And in case you're not sure about what I just explained, I'll leave a link below in the description, which is a lesson that explains this concept. So we can write work done by gravity as Wg is equal to force of gravity into 5r minus r. So what you get is work done by gravity is equal to mg times 4r or 4 mgr, which is the same as what you got here. Okay, now with the concept clear, having solved part A, we can quickly move through the other questions. In B, the displacement between initial point and the top of the loop is 5r minus 2r or 3r. So work done by gravity is equal to Fg into 3r, or that equals 3 mgr, which when you calculate gives you 0.11 joules. The next question is, if the gravitational potential energy of the block is taken to be 0 at the bottom of the loop, what is the potential energy when the block is at point P, at point Q, and at the top of the loop? So at P, y is equal to 5r, therefore u is equal to 5 times mgr, which equals 0.19 joules. At y equal to r, that is point Q, we have u is equal to mg times r, which when you calculate gives you 0.038 joules. And finally at y equal to 2r, at the top of the loop, we find u is equal to 2 times mg times r, which equals 0.075 joules. And the last question is that if instead of just being released, the block is given some initial speed downwards along the track, do all the answers you've just calculated decrease, increase, or remain the same? Now you can clearly see that this new information, that is initial speed not equal to 0, is not involved in any of the preceding calculations. Therefore the above results are unchanged.